Well, good morning, my algebras. We're going to look at simplifying rational expressions part 2, and we're going to go ahead and do this by starting with a you try warm-up to remind ourselves how we did our simplifying radicals 1. And we first look at if we can reduce the fraction. Now these are families, so I know I have to factor first. So I factor out a binomial. When I factor out a binomial, I can just do the reverse process of distributive property. So I'm going to divide off a common factor, which is 5m to the third power on the top of our fraction and 10m on the bottom. And now I can reduce the 5 and the 10 and the m values, ending up with m squared times m minus 3 over 2 times m plus 4. Now I don't need to do any more. I don't redistribute. I just leave it alone. Okay? So let's go ahead and look at what we're doing this time. And we're going to continue with simplifying, right? We're going to take off a GCF like we did before. And we see now we get to actually reduce by an entire family, that x plus 3, right? And we get x over 3. And I want to make sure that I'm not doing this, where I'm not cross canceling like this, because of this addition here. Because anytime I have addition or subtraction, it makes it a family. So if you need to put parentheses around these immediately so that you know these are families, so you don't make an error like that, okay? So that would not be true. All right. So let's talk about excluded values. After I have factored, right? After I've factored, there are certain numbers that I can't have be the solutions because it will make the denominator 0. And if the denominator is 0, it's called undefined. We don't divide by 0, right? So if I just have 2 over x minus 4, the only value that x cannot be would be 4, right? Because if it was 4, it would be 4 minus 4, which would be 0, and 2 divided by 0 is undefined, right? It's undefined, so it's excluded. The only value we cannot have for x would be 4. We call these excluded values, okay? Only in the denominator. So in this, it obviously would just be 0. So you set whatever the denominator is to equal 0 and then solve for whatever the possibilities are. So we know in example B, the only value that x cannot be is 0, right? The excluded value is 0. Okay, let's find the excluded values, if there are any, right? Let's see, for these few problems here. So I'm going to give you a minute to factor if you need to and see if you can figure it out. You can pause your video here if you would like. So on the first example, it's kind of obvious that you cannot have x be 0. On the second value, right, I would first, I could go ahead and solve, but I could also factor first. But I'm going to solve, and I know the only value it can't be is -7, right? On number 3, I'd have to factor first, and we would see, but I could have just solved this by reading too, that the only values it cannot be are plus or minus 3. Plus or minus 3. Okay, so now we're going to go ahead and simplify some more and list out any excluded values if possible. So first we need to simplify. We factor first, and then we look to see what x could not equal, right? So now we know that x here could not be -3, right? Can't be -3. Again, on number 2, we're going to factor first. And here you can look at it. What can x not be? Well, x we know it can't be 2, right? Or 0. Because here, if it was 0, right, it would cause a problem because this would become 0, and then anything multiplied by 0 would become 0. So we go ahead and factor first. We're using our X box here. 2 things that multiply to be -8 and add to be -2 are going to be -4 and 2. And then what multiplies to be -20 but adds to be a +1, that's 5 and 4. And then we can first solve for our excluded values while it's factored, right? So we can see that we don't want to have it be a +4 here or a -5 there, right? And then we'll go ahead and solve because we factor out the x minus 4. And we know our excluded values would be -5 and +4. We take out a GCF on both of these. And then before we're done with this, we would go ahead and, we also see that difference of 2 squares there. We solve for our excluded values first, right? We can factor it out. So now we know it cannot be plus or minus 5 or 0. So 3 excluded values in this one, right? And then we get the final reduced answer. Okay, we're going to do one more you try, and then we're going to go ahead and do a practice of this today, and you also have a quiz. Alrighty. Okay, have a great day.